Hey there, folks. This is Mr. Young, and I'm going to explain to you the law of conservation of matter. Okay, so imagine that we've got a chemical equation represented by these Legos here, and we've got some compounds and elements on the left that we start with. Those are called the reactants, and those elements and the compounds maybe break apart. The elements rearrange themselves to make some new products. Okay, we've got a different element here and a different compound here than what we started with. Now, first question I'm going to ask you, is this a balanced equation? Well, yes. A balanced equation is one where we've got the same number of each type of atom on both sides of the equation. Okay, so we've got two of these yellow atoms, two of these yellow atoms, two of these blue atoms, two of these blue atoms, two of these red atoms, two of these red atoms. So this is a balanced equation. And these are called the reactants that you start with, and these are called the products that you end up with. Okay, now here's another way to think about it. What if we knew that, okay, this Lego piece, this compound has a mass of 10 grams, this one has a mass of 10 grams, and this one has a mass of 12 grams. Okay, and then these things that are produced, well, we know that this big one with the red and the blue has a mass of 20 grams. We don't know the mass of this one. How could we figure it out? Is there a way to figure out the mass of this when we know the mass of all the other things, all the things that are reacting together, and the one other thing that is produced? Well, sure there is. It's like a little puzzle, okay? We could say that on the left side of the equation, we've got 10 grams plus 10 grams plus 12 grams. And on the right side of the equation, we got 20 grams plus X. And that big arrow in the middle, that's just our equal sign, okay? Now, you've done things like this in math forever. Okay, we take the things on the left, they add up to 32 grams. The things on the right, 20 grams plus X. How do we get X by itself, or how do we solve for X? We say minus 20 grams, X equals 12 grams. Okay, what you just did is you solved your first conservation of mass or conservation of matter problem. Okay, so that there must be 12 grams of this because the total mass that we start with has to equal the total mass that we end up with. The law of conservation of mass, or of matter, says that matter cannot be destroyed and it cannot be created from nothing. The conservation means to preserve something or to not destroy it. Okay, so you can't destroy mass, you can't create it from nothing, so the mass at the beginning of a chemical reaction equals the mass at the end of a chemical reaction. Let's do a couple examples. 100 grams of potassium chlorate, okay, that's KClO3, are used to produce 60 grams of potassium chloride, that's KCl, in this reaction. How much oxygen is also produced? Well, so this is our reactant. These are our products. Sometimes you have multiple reactants. Sometimes you might only have one product. In this case, we have one reactant and a couple products. We've got 100 grams of this that we start with. We've got 60 grams of this, and we don't know how much oxygen, but we can figure it out because the arrow is our equal sign. And then over here among the products, we need a plus sign. We're trying to figure out what is X. We just make a little equation. 100 equals 60 plus X. Where the arrow was, that's where our equal sign goes. Take away 60 from both sides. X equals 40 grams of oxygen. 40 grams of oxygen will be produced. If we start with 100 grams, we have to end up with 100 grams. Mass or matter can't be destroyed, and it can't be created from nothing. Here's another kind of example you might see talking about conservation of atoms. Which of these four equations shows conservation of atoms? Hit pause and see if you can figure it out. Only one of them actually has the exact same number of each type of element on both sides of the reaction. Hit pause. Okay, hopefully you didn't get tricked. Hopefully you figured out, oh, choice number 3. On the reactant side, there are 4 hydrogen and 2 oxygen. And on the product side, there are 2 times 2, 4 hydrogen, and 2 times 1, 2 oxygen. All the other answers have different numbers of hydrogens and oxygens on both sides of the reactions. Okay, here's one more example. Determine the total mass of copper. Okay, copper produced when 1.08 grams of aluminum reacts completely with 9.58 grams of CuSO4 to produce 6.85 grams of Al2SO4 We can start filling in what we know. We are trying to figure out copper. That's our X. We know there's 1.08 grams of aluminum, 9.58 grams of CuSO4, and 6.85 grams of Al2SO4 Our equation is almost done. X is what we're trying to figure out. So we'd say 1.08 plus 9.58 equals, the equal sign goes where the arrow is, 6.85 plus x. Okay, so simplify it to 10.66 equals 6.85 plus x. Take away 6.85 from both sides. X equals 3.81 grams of copper. Okay, so in the end, the total mass of the reactants equals the total mass of the products. And remember, you need to totally ignore the coefficients when you're doing these mass or conservation of mass problems. Okay, when we did this problem, we knew that there were 100 grams of KClO3 to start, 60 grams of KCl, and we didn't know the amount of oxygen. But when we solved this, we did not do any kind of multiplying by the 2 or the 2 or the 3. Okay, this starts with 100 grams total, and it produces 60 grams of this and some number of grams of this. So it's just grams on the left equals grams on the right. Are those coefficients important? Sure they are. They're important for balancing the atoms, but they're not important when you're dealing with the mass on the left and the mass on the right. Okay, and now please make sure you try that blue practice sheet. The key is on the back. These should be pretty easy. The mass on the left equals the mass on the right. Have fun.